angles in degrees measures. So whenever we talk about angles in degree measures, you'll notice we're going to talk about the unit circle. In the unit circle, you can take it and put it on top of a Cartesian coordinates, and you'll be able to determine the quadrants. Like there's quadrant 1. And we start with degree 0, and we go around 30 degrees, 45, 60, 90 degrees, and that's the y-axis. And then we keep going 120, 135, 150, 180. There's our straight line. It's on the x-axis. And so on, you go around. So you got the second quadrant, third quadrant, and the fourth. So this is talking about the degree measure of angles. And then we have some examples here. We have an acute, we have the straight line, we have the quadrantical angle, the right angle, and the obtuse. These are really good things to know, guys. And it shows the different angles. So whenever we talk about angle, it's defined as a union of two rays with a common endpoint. So we have, here we go, we have two rays. So here's a ray, and this common endpoint's right here where they're connected. This here shows that we have a ray from A to B and then B to and on. Angles is often thought of as being formed by rotating one ray while away from a fixed. So here we go. We have a terminal side. We have the initial side. So on the initial side, we have the angle that goes up to the terminal side. All right, coterminal angles. When we talk about coterminal angles, we have two of them here. We have the alpha and the beta. And they're coterminal if and only if there is an integer case such that the measure of beta equals the measure of alpha plus k, which is a constant, times 360 degrees. Why 360 degrees? Because that's a complete circle. And if you'll look right here at the top, you'll see that when we come up to here, we get 330, and then right here is where you'll see the 360 degrees. Okay. So here is a picture of the unit circle. It has the order pairs. So whenever we talk about the Cartesian coordinate, we're talking about points on a graph too, and it's always x comma y. Whenever we're talking about the unit circle, the x becomes our cosine and sine becomes my y. And we still have the same rules that in quadrant 1, they're both positive. Quadrant 2, cosine's negative, sine is positive. Quadrant 3, they're both negatives. Quadrant 4, cosine's positive, sine's negative. And then we have the order pairs of their exact value. This is radians. It's measured in radians. And then this is degrees. And whenever you use your calculator on these to determine certain points, you need to make sure you're in degrees or radians, depending on what we're solving for. All right, so let's do the first question. It's asked is an angle of theta is in blank if its vertex is at the origin of a rectangle coordinate system and its initial side coincides with the positive x. Well, that is said to be standard position. An angle with a measure between 90 degrees and 180 degrees is obtuse. The obtuse is greater than 0 degrees, but less than 90 degrees. A minute is the 1/6 of a degree. Okay, so let's work this next one. Let's give ourselves some room. So we're going to find the degree measures of the next two positions. So, and the previous two negative angles that are coterminal with the angle of 85 degrees. All right, so let's solve for it. What I know is I have a measure of beta, is equal to a measure of alpha plus constant K, 360 degrees. All right, we are giving an angle, right? And this one, we're going to let it be the measure of alpha. And then we're going to plug in. So we're going to substitute, right? Because we need to figure out what is beta. Well, first, let's plug it in. So I got the measure of beta is equal to 85 degrees plus K, 360 degrees. All right, now to find beta, we need to find some points for K. So if K is a constant, let's let K be equal to 1, -1, 2, and -2. And that will give me some points, right? So if we create our table and say when K is equal to 1, then we got the measure of beta is equal to 85 degrees plus 1 times 360 degrees. Well, that's just 85 plus 360 degrees, which is equal to 445 degrees. Okay, so when K is 1, we get beta of 445. Now let's do when K is equal to -1. So in the place of K, I'm going to plug in -1. Well, negative times positive is negative. So now I got 85 minus that 360 degrees, which gives me a negative 275 degrees. Guys, if you have issues with signs, what you need to do is say, okay, I have $85 in the bank and I spent 360. So you're in the hole. So sometimes that will help you. Now let's put a box around that. So when it's K, when the constant's -1, my beta is a negative of 275 degrees. Now let's plug in when K is 2. So we'll get the measure of beta. It's equal to 85 degrees plus 2 times that 360 degrees. So let's go ahead and multiply this out because we got to multiply first before we add. And when we do that, we get, let's see, 2 times 0, 2 times 6 is 2, carry the 1, 720 degrees. And now let's add those two together and we get 805 degrees. So when the constant K is 2, we get 805 degrees for beta. And I just want to clean this one up. It was a little messy here. Just clean it up. All right. Now, when K is equal to -2, we get the measure of beta is equal to 85 degrees plus -2 times that 360 degrees. All right, so negative times positive is negative. 2 times 360 is 720 degrees. And now we're going to subtract. And when I subtract that, I get a -635 degrees. So when my constant K is -2, my beta angle is a -635. And whenever we're talking about graphing that, when it's a negative, we're going the other direction. But we're still making the circle. Okay. So now let's talk about this next one. We want to find the degree measures of next 2 positive and the previous 2 negative angles that are coterminal. I actually worked this one out. I thought it would be great to see it. We were given an angle of a -77 degrees. And what I did is I plugged in for K is 2, -1, -2. Here I plugged in 1 and I should have went ahead and wrote it as 1 times that, but we know 1 times 360 is just 360, subtract it. So this is just an example of how to work it. I thought it would be helpful. So whenever we have an alpha of an angle of negative 77 degrees, and we have a constant K of 1, we get a beta angle of 283, and so on. So the next one says determine whether in the given pair are coterminal. So to determine that, we need to plug it in, right? So what do we got? We got alpha and beta, and these two angles are coterminal. So that means I get 1235 is equal to 155 plus the K of 360 degrees. And we want to know, are they coterminal to each other? So if I pick points for K and determine it, we're going to find out that yes, they are coterminal angles. Okay. So let's move on. It says name the quadrant in which the angle lies. All right. This one's just a little bit easier. So we're looking at our unit circle, and we want to see where 668 degrees actually lies on there. Well, to make a complete circle, we know that we go 360 degrees. When I subtract these two, I get 308 degrees. So we know that it's going to fall wherever 308 degrees is, which is actually in quadrant 4. Okay, so let's move on. We're doing great, guys. I wanted to do, let's find the angle of least positive, the least positive measure that is coterminal with A equaling negative 82. So remember that we have a difference of 360 degrees. So what I'm going to do is I'm going to take that 82, right, and find its difference, which gives me 278. So that gives me one of them, right? So we can keep plugging it in our formula to find the other ones and so on. So that one's pretty straightforward. Let's look at the next one. So let's check out this next one here. It says match the following degree measure with its angle of a negative 45. So how do I know where a negative 45 is? I mean, we know if it was 45 degrees where that's at, that's in the first quadrant, but we're talking about negative. So I'm going to take that 360 degrees, subtract that 45. Of course, we have to borrow. So it tells me that it's 315 degrees. And where does that fall? That's still quadrant 4. This is quadrant 3, excuse me. This is quadrant 2, quadrant 1. So we know B is correct. It's quadrant 4. All right. So that is solving for angles and measures. I have another one. Let's do minutes and degrees. Let's get this one right here. Give myself more paper. Okay, so let's do minutes and degrees. What I know is that for every 1 degree, it is approximately equivalent to 60 minutes. Okay, so let's solve for it. The number in front of here, the degree, we're going to put it out front. That's my degree. Now this here is my minutes and this is my seconds. All right. So what I know is I have 4 minutes and it's going to be divided by 60, right? Because in every 1 minute, it's 60 seconds. Every 1 degree, or sorry, 60 minutes. And every 1 degree, it's 60 minutes. And I'm going to add on. Well, I got this one here, which is seconds. And what do I know about seconds? Well, it's 3,600 seconds, right? So now let's go ahead and add this out. Well, in order to add, we have to have a common denominator. I'm going to put a 1 under that. And my common denominator here is going to be 3600. So this already has it in it, so I don't have to do anything to it. However, this one does not have it, so I need to multiply top and bottom by 3,600. I need to multiply this one here by 60, top and bottom. So now I got 3,600 times 32 plus 60 times 4 plus 25. And I put it all over the same denominator just to clean it up a little bit. And now what do I get? Let's go ahead and do our multiplication. So we got 3,600 times 32, which is 115,200 plus 60 times 4, which is 240. And then we just bring down the 25 plus 25. So once I add these all together on top, I get 115,465 divided by 3,600. Let me clean that writing up just a little bit. It's hard to recognize that. So we get 465. And now when I divide, I'm going to get approximately 32.07361. Just be sure and follow the directions. It'll tell you how far to round. So my angle here is going to be 32.07361. So that is finding degrees in minutes.